Okay, so we're talking about solving by rewriting today at 10.2.1. Rewriting it, which means we're just going to change the equations to get easier numbers, which means we're going to convert things into smaller, easier numbers, because easier numbers make easier math. But if you like your calculator, feel free to carry on and just do what you do. So here's the first problem. She wants to factor this, find the zeros and x-intercepts, and you could use the quadratic formula. This kid wants to use the zero product property, but you got a bunch of decimals. Now, if you look at the idea that 1.5 is the same thing as 15 divided by 10, and we all know that. That's how you get it. If you didn't, now you do. And if you take 15 divided by 10 and multiply it by the denominator of 10, you're going to end up with 15 because these 10s will divide out. So using that idea, we can rewrite this. But first we have to start off with x squared plus 1.5x minus 2.5. We need to make it equal to 0. Now if you take this whole thing and you multiply the whole thing by a factor of 10, so you go times 10 to everything, that becomes 10 times x squared, which is 10x squared. Then 1.5x, we know that's going to become 15x. Minus 2.5 becomes 25. And 10 times 0 is still 0. So now we have much easier, more workable numbers. It's all kind of the same thing, but nonetheless. And then we can factor this using the box and diamond. And we know that we put 10x squared minus 25, multiply those, you get negative 250, and then we have a positive 15 here. And looking at these, we can tell that 25 times 10 is 250, and 25 minus 10 is a positive 15. And then if we want to get the factors that create the area model, we could say, okay, well, let's take a 5x here, which would mean this would have to be 2x. So 2 times 5 is 10x times x squared. Then we would go with a plus 5 and then a minus 5, and we have our factors. So now we have the factors of, and we'll just kind of go over here. So now we have 2x plus 5 times 5x minus 5, that equals 0. And then we simply solve, and we say that 2x minus 5 needs to equal 0, and 5x minus 5 also needs to equal 0. And we solve these for x, swing the 5 over, and x can equal 5 over 2, or swing the 5 over, x can equal 1. And if you put those values in for x, you end up with the factors for this, and it would make it equal to 0. So that's just one little tidbit idea. So x can equal 5 over 2, or x can equal 1. I'm sorry. Positive 5, negative, negative. So x can equal negative 5 over 2 minus 1. So here's a note. Careful of your negatives. Yep, it happens to us all. Okay, so here's the next idea. So solving by rewriting. Rewriting gives you a new equivalent that's easier to solve. Bottom line, easier numbers, easier math. So if by rewriting, it becomes easier to solve. Who doesn't like that? Now, each equation can be rewritten so it's easy to solve. Our job is to try to figure it out. So that's what we're going to do. All right, so we've got 32 times 3x minus 32 times 5 equals 32 times 7. Now, if you're looking at this, you could probably say, wow, I could divide this by 32, this by 32, and then this other side by 32. And then we are left with 3x minus 5 equals 7. And that's a heck of a lot easier to solve. Swing the 5, you get 3x is equal to 7 plus 5, which is 12. Divide by 3, and x here is equal to 4. Who doesn't like that? Now, if you look at the next one, we have 9,000 x squared minus 6,000 x squared minus 15,000 equals 0. And if you find yourself saying a word over and over and over again, it is probably that number. So we have 9,000, 6,000, 15,000. So the first idea I would have is divide by 1,000. Just to see where it takes us. And so this becomes 9,000 divided by 1,000 is 9. So now we have 9x squared minus 6x minus 15 is equal to 0. And I'm looking at this and I go 9, 3 times 3. 6, 2 times 3. Negative 15, or just 15, 5 times 3. So I could divide each of these further by 3. And now we have 3x squared minus 2x minus 5 equals 0. And that is a lot easier to deal with because the numbers are smaller and it's a lot easier to get your head around it. So now we just start factoring this using our old friendly friend, the box and diamond. Unless you can figure it out, because 3 times 5 is 15. And you got to get a 2. 5 is 5 and 1. You can sort that out. But we'll just take it here. So we've got 3x squared minus 5. There's your negative 15. And then we got minus 2. And we know that 5 times 3 is 15. And negative 5 and positive 3 is negative 2. So we have negative 5x and 3x. And doesn't this look nice? So we could go 3x here. Excuse me. 3x, and then x, this would then be a plus 1, and this would be a minus 5. So now, let's make this a little smaller so it all fits on the screen. Now we'll keep going. Now we've got 3x minus 5 times x plus 1 needs to equal 0. We all know where this is headed. So we have 3x minus 5 can equal 0, or x plus 1 can equal 0. And this becomes, sorry, let's take this in one step. X, swing the 5, positive, divide by 3. X, swing the 1, negative 1. And here we are. X can equal 5 over 3, or x can equal 1. So rewriting definitely has its benefits. And so here's a problem. We have 1 over 3 plus x over 3 equals 10 over 3. The idea here, multiply through, multiply everything times 3. So this becomes 1/3 times 3 plus x over 3 times 3 equals 10 over 3 times 3. These 3's will all cancel out, and we get 1 plus x equals 10. So x has to equal 9. So that massive fraction looks kind of gnarly, but it becomes easier. Then we have over here for d, 2x squared plus 4x minus 2.5 equals 0. So there's a couple things we could do here, but let's get rid of that 2.5 so we can multiply everything like before times 10. So now we got 20x squared plus 40x minus 25, and 0 times 10 equals 0. Not a big deal. And so now looking at this, we could probably take out another number. I'm going to guess that number would be 5. Because 5 goes into 25, 40, and 20. So we're going to divide by 5, divide by 5, divide by 5. We now get 4x squared plus 8x minus 5 equals 0. Then we come back and factor this. And we get 4x squared minus 5, which becomes a negative 20. We got 8. So how do you get 20? 5 and 4, not going to make 8. But our friends 10 and 2 will. And if we have 10 minus 2, that's 8. So we have 10x minus 2x. And then factoring these out, we need to get a 2x. So I'm going to take a 2x, and I'm going to go 1 positive, which means this is 2, and this would have to be 5 positive. 2x times 5 is 10x, and 1 times 5, ooh, that's got to be a negative. Ah, here we go, negative 1. So now we have negative 1 times 5 is negative 5, negative 1 times 2x is 2x, 2x, here we're good. All right, so keep rocking this in a free world, and now we go to 2x plus 5 and 2x minus 1. Multiply those, you're supposed to get 0. So now we have 2x plus 5 equals 0, and 2x minus 1 equals 0. And so x is going to be swing the 5 negative, divide by 2, or x is going to be swing the 1, divide by 2, and there we go. X can equal negative 5 halves, or x can equal 1 half. And all that is a lot of work, but if you start seeing it, it comes out a lot easier. Okay, so here's a different problem. So Derek and Donovan are dealing with 4 to the power of 4 equals 16 to the power of x, and their job is to figure out what the heck is x. What value of x makes this work? And so if you kind of think about it, they walk through and you see their conversation there. And so they get into the idea that 16 is equal to 4 squared. And it is, because 4 squared is equal to 16. Okay, and then the other kid says, well, 4 is equal to 2 squared, and 16 is equal to 2 to the power of 4. Saying, can't you rewrite it as 2 squared to the power of 4 equals 2 to the power of 4 times x? And you probably can. So let's see. So that would be 2 to the power of 8 has to equal 2 to the power of 4x is what that would end up being. And so, yes, you can do that. So, and it's the idea here is simple substitution. It's all about substitution. So that's what we're working with. We're finding an equal value that's easier to work with, and we're replacing it in. So they want us to solve this using both methods, so we're going to do that. So the first method, we'll just take this 2 to the power of 2 to the power of 4 is equal to the power of 4. Not liking how that's written. So we have 2 to the power of 2 to the power of 4 is equal to 2 to the power of 4 to the power of x. And our other way is using 4 squared equaling 16. So using the base of 4, so we're going to replace the 16 with 4 squared. So this other way here is 4 to the power of 4 is equal to 4 squared to the power of x. And we just replace the 16 with 4 squared. Now, if we work at solving this using our multiplication or exponent rules, we have 4 2 squareds, which is going to be 2 to the power of 8, and that's going to equal 2 to the power of 4x. And since 2 to the 8 is equal to 2 to the 4x, we can then assert that 8 is equal to 4x. And if 4x is equal to 8, then 1x is equal to, ding, 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 2. And let's see if we get the same answer. So here we have 4 to the power of 4, then multiplication of powers rules, 2 times x, which is 4 to the power of 2x. Since 4 to the 4 is equal to 4 to the 2x, we can assert that 4 is then equal to 2x to keep them equal. And if 2x's make 4, 1x has to equal 2. And yes, folks, that works. So then if we look to check it, we would then say, so if x is 2, that means 4 to the power of 4 has to equal 16 to the power of 2. Now 16 to the power of 2 is equal to 256. And if we take apart this 4 squared, that's 4 to the power of 4. That's the same thing as 4 to the 2 times 4 to the 2. Because we have 2 4s and 2 4s, that's 4 4s. Which is the same thing as 16 times 16, which is exactly what we got. So yes, that works. So x definitely does equal 2. Now, we're going to work at this the same kind of way. So solve this. So we know that 9 is equal to 3 squared. So we could say that 3 to the power of 5 is equal to 3 to the power of 2 to the power of 2x, which means 3 to the power of 5 is equal to 3 to the power of 4x. So 5 is equal to 4x, so x is equal to 5 over 4. Yes, a little bit nutty, a little bit freaky, but it's all good. So that's how we rock that. Put that right there. So there we go. Okay, so now we're going to solve each for x. So we have, looking for things that are the same, we have 2 to the x plus 3 equals 2 to the 2x, so we can assert that x plus 3 is equal to 2x. Swing the x, 3 is equal, take away an x is equal to 3. That came away pretty quickly. You could probably check it and say that that becomes 2 to the power of 6 is equal to 2 to the power of 6. And of course it is. So now we have 3 to the 2x plus 1 equals 3 to the 3. And since the bases are the same, we can say that 2x plus 1 is equal to 3. And then therefore 2x is equal to 2, so x is equal to 1. And we can check that by saying that 3 to the 2 times 1 is 2 plus 1 is 3. And that needs to equal 3 to the 3, and of course it does. So now we have 9x. We already know that 9 is 3 squared to the power of x is equal to 3 to the power of 40. And so this becomes 3 to the 2x is equal to 3 to the 40. And if you're already ahead of me, you know that x is equal to 20. And then we have here 8. 8 is equal to 2 to the power of 3. So that's 2 to the power of 3 to the 70 is equal to 2 to the power of x. 3 times 70. Wow, that's 210 is equal to 2 to the x, so we can then say that x is 210. That's a bizarre question, but guess what, folks? You just solved a massive exponent. Now, that's the entire lesson. Take a look at it again if you need it. Please do not forget the review and preview, because they become the practice problem sets, and I'm available from 8 a.m. until 3 p.m. for any questions via Remind. So stay healthy, stay informed. That's all I got.